Hello everyone. In this section, we are going to study 2.5 Gaussian Elimination. So in the last section, we learned the row echelon form, right? Because that's the preparation for solving a linear system. So that's the just preparation for today's class. So the goal for this section is this. We want to find the solution of a linear system just by using row operations to the augmented matrix. Okay, for example, if we have augmented matrix like 1, 2, 3, 4, okay, like this, and 0, 0, 1, 2, okay, and here, for example, 0, 1, 2, 91. This is an augmented matrix. That means the left side is coefficient matrix and right side is constant b. So from the last one, you can see x3 equals 2, right? If we look at the last row as last equation, so this is x3 equals 2, and then we use back substitution, find x2, x1, something like that. Let's see. First example, we are going to determine the solution set to this linear system. So first step, for this kind of thing, we want to write down the augmented matrix. So let's see. That means we pick all the useful information for this matrix. Augmented matrix means coefficient matrix together with constant b. So we need to write down b also. Here 1, -2, 1, 5. 2, -1, -2, -1, and then we want to reduce this to row echelon. Okay, we want to find row echelon form. Let's see. We did this several times. Let's just do a review. We need a leading one in the first row, so I'm going to switch the first row and the second row. 1, -2, 1, 5. This is like switch two orders of two equations. 3, -2, 2, 9, 2, 91, 91, 92, 91. And the next I'm going to use this one to make them into 0. So times -3, 6 minus 2, 4, -3, -15, and then 9, it's -6. -2 times -2, 4, 4 minus 1, 3, 1 times -2, -2 are there, -4, -10, -11, right? And the next, we need a leading one in this position. Some students may think they want to divide by 4 and find a 1, but usually we don't do that way because we don't want to create any rational number, right, fractional number. So we will just want to use the row 3 to make that into 1. So we use the row 3 times 91 added to row 2. So 0, 3, 94, 11. Here 0, row 3 times 91, 1. And the 4 minus 1, 3. 11 minus 6, 5. Right? And then we use this to make that into 0. That means row 2 times -3 add to row 3. This is number 5. So 0, 0, 3 times -3, -9, add -4, -13. -15, add -11, -26. And you can see in the last row, we can simplify 1, -2, 1, 5. 0, 1, 3, 5, 0, 0, 1, 2, right? Okay, so this is a row echelon form. We can stop here. And we treat the right side, the last column, as the right side of the equation. And if we look at the third row, that means x3 equals number 2. Is that right? x3 equals number 2. And then now we look at the second equation, second row. Okay, second row, that means what? x2 plus x3 equals 5. Is that right? If we look at the second row and solve x2 from there. 5 minus 3 x3, which is 5 minus 3. Plug in x3 should be -1. And then we plug x2, x1 into, so here we have x3, we have x2, plug them into x1. So how to find x1? Look at the first row. First row means x1 minus 2x2 plus x3 equals 5. Okay, that means you can plug in now, so it doesn't matter too much. So plus 2, if we plug in x2 and x3 equals 5, so you can see x1 equals 1, right? So the solution set is, do you still remember how to write down solution? We write down them in the parentheses like this way, right? So be careful the order. x1 in the first position, x2, and then x3. So this is the solution set. This is how we solve the linear system. And here we have the exercise problem for you. You can try. So the first step, we always want to write down the augmented and do the row operations, find the row echelon form. After we find the row echelon, we can use back substitution to find the solution. Okay. Please do this problem by yourself, but I'm going to give you the solution. You can check with my solution. Augmented matrix. Reduce into row echelon. I skip the middle steps. Okay, the row echelon form of this one is pretty easy. 0, 0, 1, 1. So you can see the last row means x3 is 1. Okay, and x2 equals -2x3, so it should be -2. And solve x1. x1 actually is 4. Okay, that is the solution. Let's take a look at definition. It's called Gaussian elimination. That means the process of reducing the augmented matrix to row echelon form and then use back substitution together with substitution to solve the equivalent system is called Gaussian elimination. So definition for Gaussian elimination. Okay, that means what? The process. So it's include 2 processes. Reducing first step, reduce augmented matrix into row echelon. After we get that, we use back substitution to solve the system. Then using back substitution to solve the equivalent system. Okay, and if we reduce the augmented matrix into reduced row echelon, is called Gaussian-Jordan elimination. So the next definition is Gaussian-Jordan Jordan elimination. That means what? That means if we reduce when the augmented matrix, okay, like we just write down this way, is reduced to reduce the row echelon. Do you still remember what the reduced row echelon look like? Okay, so for example, if we have reduced the row echelon form is like 1 0 0 1 0 1 0 2 0 0 0 3. So let's see, this is a reduced row echelon because in each row, each column with leading one, all the other numbers are 0, right? So this is a reduced row echelon. So you can see what the solutions are. You can easily tell from this one, x1 is 1, x2 is 2, x3 is 3. We don't even need the back substitution. So this is called Gaussian Jordan elimination. Now let's take a look at example 2. Let's use Gaussian Jordan elimination to solve the linear system. Okay, the linear system is given by this one. Five x2 here, x1 plus 3x2 2x3 equals 6. So first step, definitely write down the augmented matrix. Let's pick all the coefficient and the constant. A pound equals 2. Okay, so this is 1 2 91 1 2 5 91 3 and 1 3 2 6, right? This is augmented matrix. And next step, we reduce this into reduce the row echelon. Okay, so let's see, definitely we use this one to make them into 0 1 make into 0, so times -2 2 times -2 here 5 1 times -2 +2, so it should be like this. All right, and the last row, which is times -1, so 0 1 3 5. Okay, and reduce the row echelon means those two should be 0, so we use row 2, the leading one in the row 2, to make them into 0. So row 2 stay here. The first row become times -2 0 times -2 3 1 times -2 right there, and add 2 times 91, add to row 3, so should be 2, should be 4, right? And we need the leading one in the last row, so divide by 2 in the last row, and let's write down them. This is not reduced row echelon because in the last column we need them to be 0. Okay, so we use this one to make them into 0. Use row 3 times 91 times +3, add to row 3 and row 1, so 0 0 1 2. Let's see, here 0 1 times row 3, the 91 times 91, add there 0, and 2 times 91, add 1 91 1 0 times 3 0 2 times 3, like this. All right, so we can see this is reduced row echelon because we can tell we have there's leading one in each row echelon, and then each column 1 is the only number. So the solution for this one, you can see if we look each row as equation, so x1 equals 5, x2 equals 91, x3 is 2. So this is the solution. Okay. In the future, you can use any method to solve a linear system. You can use Gaussian elimination, or you can use Gaussian Jordan elimination. Usually we just use Gaussian elimination and then use back substitution. I think that's easier, but you can use either one. Okay. In the future, we will also learn how to find the inverse matrix. So when we finding the inverse matrix, we will use Gaussian Jordan method, like reduce the row echelon form. Okay, and now let's take a look at example 3. So for example 1, example 2, you can see those linear system has only one unique solution, right? But right now, because we know for some linear system there may be no solution, sometimes there may be the solution may has infinity solutions. So let's take a look. Example 3, determine the solution. So let's see, just say find the solution set to this linear system. Okay, x1. This is, you can see how many unknowns we have here. For this linear system, we have 4 unknowns, right? So what's the first step? Write down augmented matrix. And be careful. So should be 1, 1, negative 1, 1, that's coefficient, and B, right? And 2, 3, 1, x4 coefficient should be 0 because there's no x4. And 3, 5, 3, negative 1, 5. This is augmented matrix. Now let's reduce this into row echelon form. Okay, row echelon. So I'm going to do this a little bit quicker because we can make them into 0 easily. Negative 1, 1, 1. And times negative 2, times negative 2, times negative 2, positive 2, 3, negative 2, 2, times negative 3, 2, negative 3, positive 3, 6, negative 3, negative 4, negative 3. Then we want to reduce this into row echelon. We use 1 to make that number into, make this 2 into 0, right? Row echelon. So when we calculate, we times multiple by negative 2. All the numbers, first several numbers are all zeros, but 2 last number in the second row. 2 times negative 2, negative 4, add 2 should be negative 2. So this number is negative 2. Now let's take a look at the last row. Last row means what? Means, do you still remember for the augmented matrix? The last column means the right side of the equation. If we look at the row 3, that means 0 equals negative 2. That is impossible. Is that right? Impossible. So in this case, that means there's no solution because this is we also call that inconsistent. This system is inconsistent. Okay, so let's select this one. Let's take a look at the rank of A and the rank of augmented A pound. Let's see, what's the rank? For the rank of the matrix A, we just look at the first just 4 columns, right? So this is like A, and A pound is the whole thing. So what's the rank? We can just hide the last column. What's the rank? Rank should be the number of non-zero rows should be 2. Is that correct? But if we look at the rank of A pound, so there's no non-zero row, the rank is 3. So you can see, actually, when the rank of A is less than the rank of A pound, the system is inconsistent, actually. Okay. We are going to have a conclusion at the end, but right now you can have a little bit idea. Next example. Let's see. We have linear system, same thing. We want to find the solution set. this linear system is 5x1 minus 6x2 equals 4, and 2x1 minus 3x2 plus 1, 4x1 minus 3x2. Same thing, write down the augmented matrix. 5, negative 6, 1, 4, and do row echelon. 1, 4, negative 3, negative 1, 5. Reduce this into row echelon. So we need a leading one. We did this several times. I'm going to use the row 3, like a negative 4, add to 5 to make this into 1. So it's like row 3 times negative 1, add to row 1. So row 2, row 3 keep the same. Copy row 3, row 2. Here's 5. And let's become 1 because negative 4, right? And positive 3 add to negative 6. This time negative 1 to negative 1. We have leading 1, and then we use leading 1 to make them into 0. 1, negative 3, 2, negative 1. So I'm going to do this a little bit quicker. 3, negative 3, 3, 0, 9, negative 9, 9. Okay, and let's see. For the second row, we can divide them all by 3. 1, negative 1, 1, right? And the row 1 still the same thing. And the row 3 and the row 2, you can see they are totally same. Proportional, not exactly same, proportional, because it's like row 2 times negative 3 add to row 3 can make row 3 into all the rows. So in the future, like before I said, if we have, for example, if we have like this kind of thing is at the same rows, we can just make the last row into 0, right? But if the row is like this way, proportional, we can also make them into 0 because same thing, same method. Let's take a look at this linear system. What's the meaning? Let's take a look at the second equation. Okay, second equation. And the first equation. The first equation means x1 minus 3x2 plus 2x3 equals negative 1. Second equation means x2 minus x3 equals 1. And the third row is 0 row. It doesn't give us any information, right? So in this case, we want to say there is a free variable, so we can solve the second equation. Second equation here, okay? This is second equation. Solve for x2. x2 equals 1 plus x3, and x1 same thing. x1 equals to, let's see, move everything to the right side, 3x2 plus 2x3 minus 1, and we plug in x2. Okay, so we don't have to write down this. Firstly, solve for x2, 1 plus x3. Okay, and solve for x1. x1 equals 3x2 minus 2x3 minus 1, and plug in x2. So 3, 1 plus x3 minus 2x3 minus 1. Simplify this one. We can express x1 in terms of x3. So 3 plus 3x3 minus 2x3 minus 1. Simplify, so it should be 2 plus x3. So let's linear system, if we want to solve this one, we can only get those information. x1, x2, they are all in terms of x3. In this case, we say x3 is the free variable. Okay, so we say we can set x3 to be free variable. And usually for the free variable of parameter, we set x3 to be t. And x2, in this case, which is 1 plus t, and x1 is 2 plus t. So the solution set, we write down this way. Solution set is s equals to, we write down x1, x2, x3. So x1 is 2 plus t, x2 1 plus t, x3 is t, and here t can be anything, belongs to R. Okay, so in this case, this linear system has infinite solutions. Infinite solutions. Okay. Don't worry too much. So in the future, I'm going to show you which one should be the free variable. So if we look at this matrix. Okay, who has leading 1? x1 has leading 1. And this position is x2, right? x2 has leading 1. That means x2, x1 can be solved. So who has no leading 1? x3. Then in that case, we just set that variable who has no leading 1 as the free variable. So in that case, we set x3 to be the free variable. Now let's take a look at this exercise problem. Three x1 minus x2 equals 1. 2x1 7x1. Okay, let's write down augmented matrix. So should be 3. Be careful, x3 here should be 0, right? Because no x3. 2, 1, 5, 4. 7, -5, -8. -3. Here I'm going to just give you the row echelon form, so just save you some time. But you should know how to make this change this into row echelon, right? 0, 0, 0, 0. Okay, let's take a look at this row echelon form. In this case, you can see x1, x2 has leading 1, x3 has no leading 1. So who is the free variable? x3. We set x3 equals t. And then solve for x2. x2 is from the second equation, right? Second equation. So which is -3x2. So -3t actually plus 2. And then plug into x1. x1 equals 2, x2 plus 5x3 minus 3. For those two, we change the sign because they move to the right side of the equation. They change the sign, right? But for the -3, it's already on the right side, so we don't change the sign. Be careful. Just look at that as one equation. And then now plug in x2, x3. So 2. 5t minus 3, simplify. Should be -t plus 1. So the solution set should be, we write down this way, okay, x1, x2, x3, x2, -3t plus 2, x1, -t plus 1, and the t belongs to R. So here's the solution.